right, here's our video for simplifying trig expressions. We did 1 through 8, and I let y'all have time to do that individually together or alone, kind of as a warm-up, reviewing the material from the day before. So pause the video here and just try those problems and then come back and check your answers. And then in this video, I'll do the problems that were a little more complicated that we did together in class. So pause the video here. All right, we're going to look at 9, 15, 17, and 20. In this video, I think they're good representations of different skills that you need for some of the problems. So looking at 9 first. And as a reminder, there is more than one way to do a lot of these problems. So this way I'm going to do here might not be the same way I would do it if you gave me this problem fresh tomorrow. It might not be the same way you do it or your partner. But as long as you're doing good math throughout the problem, we all arrive at the same place. Right, so what I'm going to be doing on number 9 is thinking of ways that I can rewrite these expressions as trig ratios or as Pythagorean identities. And what I mean by trig ratios is these ratios from our previous unit. For example, you can rewrite tan as sine over cosine. Sometimes you might want to rewrite it as 1 over cotan, depending on your goals for the problem. And then these Pythagorean identities that we constructed in the previous day's lesson. So using these and looking at problem 9, I would probably start this way. I would rewrite secant theta as 1 over cosine. Now I'm not going to write theta throughout the problem. I'll put it back in at the end. That will just save me some time in writing. And then minus sine times tan. Now sine I can't rewrite, so it's just going to be sine times tan, which is sine over cosine. Now here in this part, the way I have it set up now, for this second term, I have really a sine over 1. So what I'm going to do next is focus just right here, and I'm going to multiply the numerators and the denominators. So that is fraction math. And I've been putting a fraction review video in your Google Stream announcements every day, so check there if you want some help with your fraction skills. All right, so now I have two fractions being subtracted, and they already have a common denominator. So what I'm going to do is combine them into one fraction with that denominator. Now notice when I was multiplying, I multiplied the denominators, but when you're adding or subtracting, you're not. So if the denominator is the same and you're combining these into one fraction, you just keep that denominator. And then combine the numerators. 1 minus sine squared. Now we have a property that says 1 minus sine squared is equivalent to cosine squared. So these things are equal, therefore they can replace each other or substitute for each other. So for this entire expression, 1 minus sine squared, I can replace the entire thing with just cosine squared. And cosine squared over cosine simplifies to 1 cosine of theta. And if you that's basic exponent math, but if you want to see it in a little more detail, cosine squared is cosine times cosine. I can cancel one pair of those, and that leaves me just with cosine. Another way you can think about it is when dividing expressions with exponents, you are subtracting the exponent. So 2 minus 1 is just cosine to the 1, or just cosine theta. All right, next I want to look at 15. Now 15, the directions to the whole worksheet say simplify each expression to a number or one trig function. I haven't been able to figure out how to do that on 15. There is some additional properties that we can use to do that, but we haven't learned them yet. So 15 is an outlier in that I can only get this down to 2 terms, but I want us to talk about it anyway. So the reason why I want to touch on this problem is I have difference of 2 squares here. Remember, our difference of 2 squares factoring property says if you're subtracting 2 things that are perfect squares, you can write them in factored form by square rooting each of them. So the square root of this gives me A, and the square root of this one gives me B. And you can make a minus version and a plus version. Well, how that would look here, because I am subtracting 2 perfect squares, the square root of something to the 4th power is that thing to the 2nd power. Because this times itself when you're adding exponents is 4. So if I'm rewriting this with difference of 2 squares property, I get this. Now, in the second group, sine squared plus cosine squared, we know from our Pythagorean identities that sine squared plus cosine squared is equal to 1. So 1 can replace this entire expression when we see it. So I do see it here. So this can be replaced with 1. And 1 times this is still sine squared minus cosine squared. But now I have difference of 2 squares again. But even if I rewrite this as sine minus cosine, sine plus cosine, square rooting everything, it doesn't really move my math forward. I can't plug in anything else here, so I'm just going to stop here and make that my answer. But mainly I wanted to talk about this problem to bring to your attention the difference of 2 squares property. Okay, I want to talk about 17 together. On 17, I am going to start by rewriting my trig identities. I can't rewrite sine, so it's going to stay that way. I can rewrite tan as sine over cosine. And on the bottom, I can rewrite secant as 1 over cosine. So now I have a fraction with fractions in the numerator and denominator. This is called a complex fraction. And usually we handle that by doing a keep, change, flip situation. Keep the numerator the same, change this division to multiply, and then flip the bottom fraction, or the denominator. Now the issue here is I can't flip the denominator when it's 2 different terms, because you can't flip them individually. You have to flip it as one expression. So I can handle that by combining these into one fraction. And then if I do that in the numerator also, I will end up with a fraction times a fraction, and I can see what might cancel and so forth and so on. So I'm going to rewrite these expressions with common denominators first. So looking at just the numerator, this sine term is over 1. So making common denominators here, 1 and cosine multiplied together would give me a common denominator of cosine. So to rewrite this first fraction with that denominator, I multiply bottom by cosine and top. The second fraction already has that denominator, so I don't need to rewrite it. So now I'm going to combine these 2 fractions into 1 with the common denominator of cosine. And in this first term, I multiply the numerator as cosine times sine. And then plus the second numerator, which is just sine. Now I'm going to do the same thing in the denominator. This one is over 1. A common denominator for 1 and cosine is cosine again. So the first fraction I'm going to multiply cosine bottom, cosine top. The second fraction already has cosine denominator, so I'm combining these two fractions into one with the common denominator of cosine. In the first fraction, I multiply the numerators, cosine times 1, plus the other numerator of just 1. So now I have just one fraction over one fraction. I'm going to keep this one the same, change this division to multiply, and flip the bottom fraction. So now when you're multiplying fractions, any numerators or denominators that match can be canceled. So I'm canceling here. And then in this numerator right here, or let's look at what I have right now. Now, remember our goal is to simplify this to one number or one trig function. And right now I don't really have that, but if you notice in the numerator, there's a GCF of sine in both of these terms. So if I factor that out as a GCF, I'm left with this. And you can check by distributing that that would work. And now the cosine ones cancel, and I'm just left with sine, and I'm going to add my theta back in, and I'm done. Okay, now I want to look at number 20. What I'm about to show you for number 20 is a helpful way of simplifying the math for a few moments. I'm going to do this. I'm going to let x replace cosine and y replace sine. So everywhere I see a cosine, I'll put in an x, and everywhere I see a sine, I'll put in a y. These are just going to be temporary placeholders until I get myself to a point where I can't do any more math with the x and y, and then I'll put cosine and sine back in. So now it kind of makes it easier to see what I can do here. 4x minus 3y quantity squared means 4x minus 3y times itself. Then plus this quantity squared, which means 3x plus 4y times itself. And I want you to pause the video, and I want you to FOIL these two, and then combine your like terms, and then we'll catch back up from there. Okay, here from 16x squared to 9y squared is the FOIL for the first pair of binomials. Here to here, 9x squared to 16y squared is FOILing the second group of binomials. Then I've combined like terms. I combined the x squareds, the y squareds, negative 12xy, positive 12xy's. The xy's canceled because one coefficient was negative 24, the other was positive, and so I'm left with 25x squared plus 25y squared. Now I notice that these two terms have a GCF of 25, so I'm going to factor that out. And there's no additional math I can do with this x squared, y squared. That is how I know to plug my cosine and sine back in. Now we know from our trig or our Pythagorean identities that cosine squared plus sine squared is equal to 1. And 25 times 1 is 25. So the rest of the problems from that lesson are for you to work in practice, and the PDF key is in your Google Classroom.